Good evening, everyone. This is Brenesh. Um, I lead the mainframe modernization COE within Wipro, and I'm part of the integrated digital engineering apps team, right? I mean, ideas within Wipro. So we quickly wanted to talk about mainframe modernization and how Yugabyte can be a part of it, right? I mean, so to get started with, we wanted to see there are quite a lot of questions. Is that do we really have legacy, and is there a market for legacy? Absolutely, yes. I mean, if you look at the State of Cloud 2020 report, even today, more than 71% of the companies still rely on mainframe, and then they clock 30 billion transactions a day on mainframe itself, right? And then now more than 90% of the overall credit card transactions in the world still goes through mainframe. And interestingly, another factor is also from Z system has clocked more revenue in 2019 because of their Z15 system, because of the lot of upgrades. And then we also anticipate the market is about to be like 24 billion in 2025. So legacy is still out there. And then unlike everybody thinks, right? I mean, legacy is all batch. Absolutely no. Legacy caters to both online and batch. I mean, if you clearly look at the graph, and this is from Gartner, during the daytime, we can clearly see that there's a lot of workload which mainframe does for the OLTP processing, and then the entire batch workload happens in the night batch. So the whole a lot of mainframe workload is being busy throughout the day in some form or other. So that's how it is. So if you really have to modernize a mainframe application, you'll have to deal with both legacy online as well as the batch, right? And typically, while mainframe is all good, so what is rocking the boat, right? I mean, so there are some of the major factors which I wanted to cover for today. Increasingly, a lot of people are relying upon APIs to be exposed for their B2B partners and other stuff. And then there's been a huge, increase in the number of inquiry transactions, especially during the the holiday seasons like Thanksgiving, Christmas seasons, or during annual enrollment period and those kind of stuff, right? I mean, so is the mainframe really able to cope up with the increasing number of workload from new age channels like mobile, web, and other stuff? No, I mean, because you need a increase in hardware for the whole period, right? I mean, so and then if you also look at it, there's quite a lot of new channels and mediums which have come up. And definitely there is a need for a complete data fabric, the way in which we do it, and then need for a connection fabric, like exposing things via API and other stuff, right? And then and there is also a lot of need for a monolith app which have to be transformed into highly scalable microservices based architecture, right? I mean, so while all other factors also matters, let's look at the blue ones and how we can bring together the mainframe modernization story along with Yugabyte, right? I mean, so typically there are like multiple mainframe modernization solutions which happens, right? It's like a four. Just after you do a legacy modernization assessment, either you can do it in place, because in certain cases you cannot replace your core application as is, but then you need to extend and surround your core application. Say for example, you can just offload your inquiry transactions into the Yugabyte YSQL, right? I mean, so, and then in certain cases, yes, you might have to transform the whole application landscape itself. So that's where the re-engineering or the refactor comes in, right? And then there are other choices like rehost and migrate. But let's quickly look at how the in-place modernization, which is a very common use case across the BFSI customers, where they can simply offload their inquiry workload. Because it has to be highly scalable, and those kind of workload completely gets eligible for this kind of inquiry offload, which we typically call it as a CQRS, command query responsibility segregation. The next major one is a typical mainframe re-engineering, where you can actually simply you modernize your existing landscape into a microservices based, either be a like for like or with a top-down approach, right? I mean, under these two cases, the modernization is pretty popular. That's what we see it. And then the whole exercise is powered by moderniZ, which is Wipro's IP platform, which helps across different service extraction, data transformation, UI transformation, IAM migration, and then the end-to-end pipeline integration. So this is like moderniZ, where the Z stands for the Z system migration, right? I mean, so we will quickly take you through how moderniZ can help us transform from the legacy to the target application form. So when we talk about legacy, there are quite a lot of challenges which we need to look from a legacy, right? I mean, legacy can be a headless architecture. And if you also look at database, there could be, blob objects which might be stored within the database. So which means it needs transformation into a kind of a NoSQL database. And many times the regular OLTP will have to get into its own scalable, regular RDBMS kind of model. So it is not a single solution. A kind of a new SQL like database like Yugabyte fits perfectly here because of it's both the offerings, right? I mean, you have YSQL as well as YSQL, right? I mean, so that's how it comes into picture. And then at the same time, when we also look at it, Mainframe maintains its session state using TSQs, temporary storage queue, and temporary data queues. And they perform they help in improving the transaction response time to a greater extent. And the way in which your screens and programs are all tightly coupled, so you'll have to decouple them and then expose the services, right? I mean, so or APIs, right? I mean, so that's where when we take a look at the typical mainframe modernization, right? I mean, so it happens like you have a transcoding application which will just help you move from system X to system Y, whereas your technical debt and the way in which your whole organization remains, it's all the same thing, right? So that's how just the transcoded application happens. But then just after the transcoding, so how moderniZ will help us is, identification and generation of microservices from the generated Java services, and then you refactor those services into a microservices-like architecture, and then generate APIs, create an end-to-end pipeline, and other stuff. So the customized solution for mainframe modernization, right? I mean, we all start with the transcoding part of it. So the transcoding starts with a like modernization, where you move from your COBOL application into a Java application. But then your technical debt remains the same. Your database object remains the same. It is just a factor of moving from your COBOL to Java. But later to that, there is a lot of things which we'll need to do to get started with, right? I mean, so identification of services from this landscape, and then carving out those microservices, and then refactor those services into a proper microservices like architecture, and then completely modernize your data landscape from here. Say, for example, if mainframe has DB2 for ZOS, you'll need to migrate that DB2 for ZOS to your target cloud database, right? I mean, be it PostgreSQL or YugabyteSQL. I mean, so all the SQLs will need to be extracted and converted into the target landscape, right? And then we also look at, there's quite a lot of UI, which is 3270 based green screens. Those UI will be transformed into a native Angular or React based, so that people can actually go for a browser based. There is no more mainframe terminal emulator based or a OC Web Connect is no more required, right? I mean, so that is how it is. So, and the second use case which I wanted to talk about today is a very popular use case is CQRS. In some of the cases, you cannot get rid of mainframe assets. So under such cases, the core will still remain in mainframe, where today reads and writes happen. But tomorrow, mainframe will cater only to the writes, where the writes include your update, create, and delete. Whereas all the reads will be transformed back into a NoSQL database, which can be hosted in any of the cloud, be it GCP or Azure or Microsoft or AWS, right? I mean, so here the 3270 green screens gets converted into Angular, and then the whole business logic will still remain in mainframe for the updates. Whereas instead of the hardwired transactions between your screens and the services. So tomorrow, the services will be directly API enabled via ZOS Connect Enterprise. And then the Angular screen will start calling those services assets, right? And then the database will definitely get transformed into, kind of a NoSQL database or a Yugabyte. Again, it works on top of the Cassandra, right? I mean, so that's how it is. So they're going to quickly take you through a demo of both the use cases. Okay, so let me quickly take you through how we can transform the mainframe application into a modernized application with the help of moderniZ, with as much automation as possible, with over 50% automation across all of these different activities, what we can do. Okay, so when you look at this demo, right? I mean, so this is the mainframe environment, what we have it in our ZDNT, right? I mean, so if you look at it, the whole system is based on the keystroke based. You'll need to remember the system type, action code, and if you type in the key, directly it fetches your data from the DB2 for ZOS, and then you can see that it's all printed out here, and then the whole thing navigates only via key, right? I mean, you need to know the hotkeys and other stuff. And now, when you just migrate these with the help of your transcoding application, right? I mean, so how it happens is it will look exactly the same way what we see today. Okay, let me bring that up. So here is the transcoded application. So here in the transcoded application, if you look at it, it looks exactly the same way your mainframe green screen looks like. And here, the only change what we have done as part of the transcoding is we have just inverted the color from your typical black to the white screens. But otherwise, all other stuff remains the same. You'll need to remember the system type, action code, and if you just type in the keys, everything comes up here. So the same, the mainframe-based, the hotkeys or the power function keys have been given here, and it is fully keyboard operated. So the only thing what we bring on top of transcoding is we eliminate the need for the mainframe emulators or the OC web connects, but otherwise it looks exactly the same. So now, how do we move from this point to a modern architecture using our moderniZ, right? I mean, so when you look at the moderniZ, there are like 3 different parts of it: the UI transformation services and the data. So now let's start with the data transformation. So to quickly look at the data transformation, the first one is your DB migration, right? I mean, typically in the mainframe application, it may not have a direct connect from an external world. So for that matter, what we are doing is we are directly scanning the application code, and then we directly construct our own SQLs based on the declaration generators, which happens in mainframe, right? So just after you generate the DCL gens, then immediately we can start creating the same schema back in the distributed cloud databases. So here, if you look at it, so I'm just selecting the the DDLs what we have generated, and then you can choose the target database as Yugabyte, and then you can give all the connection SQLs, and with just a click of a migrate, we will be able to migrate the objects and the schema from system X to system Y. And again, this is a like-for-like implementation. Wherever there is possibility, say, remember certain data types and stuff which may not be fully compatible, those will be automatically being taken care of through this kind of migration. And this can also be used for a small scale data migration, which can be used for lower environments or for static data and other stuff, right? I mean, and if you look at it, on the fly, we have just converted all the SQLs, and not all the SQLs, all the objects from DB2 for ZOS into a Yugabyte, right? And then as a second part of it, which we want to talk about, is the remediate application. If you remember, I was talking about the transcoding, and that the transcoding does like for like, which means there is no SQL transformation. So within cloud, rather than going for DB2, if I have a choice, let me say that I'm going through a Yugabyte. If that is the case, I need to extract all the SQLs from the legacy application code base, and then convert them into Yugabyte compatible SQLs, right? I mean, so this actually goes through, scans through each and every one of the program. It extracts all the SQLs, which either static or dynamic or embedded SQLs. I mean, it just generates all the SQLs, and then just a matter of a click of convert, it converts them in its equivalent target database. It can work for multiple different databases, and we are currently demonstrating Yugabyte. And if you look at it, DB2 has like current space date, right? And then if you talk about Yugabyte or Postgre, it has to be current underscore date. That's how it works. And also, if you look at some other cases, like for update off within DB2, you'll have to give every column which will be going as part of your locking, right? And as part of the hold. Whereas in the Yugabyte or in Postgres, you don't have to give it. It is just a matter of for update. That's it. So similar to that, this utility takes care of all such the stuff between your legacy and the target. It understands different patterns, and then it remediates them. And this is built on top of the open source SQL base, right? And then when we look at the service extraction, so the service extraction, we have partnered with one of our partners, which is V function, and what they do is they on during the runtime they look at different patterns. What happens? We have already done the runtime analysis, and if you look at it, it gives three different colors and different bubbles, right? And then the colors represents the exclusivity of it. The ones which are pink are like highly exclusive, which means they are like more like a copybook and other kind of stuff, which are highly shared between everybody. And then there are like router programs which all come into the picture. And then the size of the bubble also represents what amount of CPU which is gathered. This tool does not have access to your source code, but then it just looks at the Java binaries and then it builds a code, right? And then we can apply quite a lot of filters, and then it gives into a meaningful set of analysis, what we can call. So here, after applying the different filters like CPU, runtime, and other filters, it just gives us like only 5 bubbles, and then it gives an interconnection between them. And these 5 bubbles are potential entry points or potential microservices which we can construct out of this. And then just by clicking off it, it downloads the service entry for this, and then we can run a tool again through the command line. We can point this service specification and we can run it against the code copy tool, which will look at the Java code and builds its corresponding microservices. There is a bit of a manual intervention required here to just to make sure that we have the right dependency on the pom.xml. We configure them with the right REST endpoints and those kind of minimal stuff which is required to make sure the microservices works well. And then just after completion of this, right? So now we have looked at the data, we have looked at the SQLs, and we have looked at the services. And then the last part is what still remains in mainframe is the UI, right? So we have built a whole UI builder, which can work on top of any of the legacy Java screens, or it can directly extract the definition from mainframe BMS or MFS maps also. And it can even work on AS400 maps too. So it looks at the mainframe landscape. So currently we are looking from the transcoded application. So this is more like a low code, no code kind of a platform what we have built. And this works like a 12 column or array based stuff where you can add or update entries for any specific stuff. And here, if you look at it, right, I'm converting the mainframe screen to this thing. So there are like different standards when we work with the customers, right? The first one could be more like enterprise-wide standards widgets, right? So which means the style gates are prescribed by the enterprise itself. They will have their own branding, color code, and other stuff, right? And the next one is going to be the domain-based widget, which is also common, right? Mainframe screens are like convoluted, where it just deals with one specific functionality, whereas in case of a browser-based, right? It has to have a menu-based navigation system. So all this different menus represents different kind of domains which exist within the system, like customer, broker, and the different functionalities which exist out there. And if you look at the third box, that is the whole application-based widget. And this application-based widget, this is what we automatically capture it from your existing mainframe application or from the transcoded application, right? And then we load them back as a widget into a repository, right? The widget can further be automated for different types of stuff. Say, for example, if you have a date field, the widget can just be adjusted to have it native. And this UI builder just works simply for both Angular as well as React, and even you can specify the Bootstrap versions too. And then if you look at the last one, it is also again an enterprise-wide widget where there is a common header and footer and other stuff, right? And just on click of a build, automatically it gathers all your dependencies. It takes care of mapping different instances, and then it also takes care of creating a right project with respect to all the dependencies and other stuff. And then it automatically hosts in a particular port also. We can configure all of this into a metadata-based repository underneath, right? And then, so just by clicking launch of it, you can see that how the good old 3270-based mainframe green screens have been completely transformed and translated into a native Angular screens. And the generated code has been reviewed by a couple of architects from different customer bases, and then it all seems to be pretty good. And then if you look at it, it's all navigated based on this thing. And since some of the mainframe customers especially ask for, they still want to retain the old system type or key-based navigation stroke. That's what you see. Even though there is a menu-based system, you still see the power function keys at the bottom, and the PF keys at the bottoms or the hard keys. and at the top you still have the system type action code and this kind of. So we have created more like a kind of a hybrid mechanism, but this can be still built as a a whole new completely native application as well. And if you look at it, right, I mean, so the functionality have been migrated, and then it creates a new number, and then this is created in the Yugabyte database directly. This is no more going to the mainframe part of it, right? I mean, so this talks about the whole mainframe modernization story, what we are talking about. Now, let me quickly take you through the second use case where we're going to talk about offloading only the inquiry part of it, whereas the maintenance, I mean, offloading only the inquiry out of mainframe, because we need to scale it for the new age channels like mobile and web, whereas the maintenance or the update or add part of it will continue to remain in mainframe, right? I mean, if you look at it, the old interface type which I spoke earlier, this is the same thing which exists right here. So what we are planning to do is, I mean, what we have done is with IBM's, the studio, we have exposed all these mainframe services into APIs. So if you look at it, the IBM Explorer helps creating APIs out of mainframe, right? I mean, it can simply expose different services using ZOS Connect Enterprise, and then this can be accessed from, your API gateway even from outside. So here, if you look at it, we have created the post and then the patch and then the put methods just from your mainframe. So which means the UI is no more going to be in mainframe, and then the tightly coupled services which we are interacting very closely with the 3270 green screens are going to be exposed as APIs for the B2B partners so that they can build on top of it, right? I mean, now we have segregated the screens and then the APIs from mainframe. So now let us quickly go back to the Yugabyte console. So what we have done is we have created a NoSQL cluster within Yugabyte, and then all of this data. See, again, I need to tell you, this is not going to be in the same structure what we have it in the mainframe. Mainframe is completely going to be in the third normal form structure, whereas the structure what we have created here, this is of JSON format, and this format is readily servable back to the online enterprises channels, right? I mean, so because we do not want it to make any operations during the runtime, and we wanted to just extract it and send the data back out here. So anytime when there is a change which happens in mainframe, automatically it will be synced back here with a low latency based update. So for this, we have exposed one more data API from mainframe, and then we have exposed the sync APIs or the sync microservices in the distributed platform also. The sync will directly, it'll run for every 5 minutes or every 10 minutes. We can do it as much as possible, or near real-time sync will continuously listen to the mainframe trigger tables, and then it will fetch the data based on the data APIs, and then it can update it back in the Yugabyte. And this can also be automated via Kafka-based messaging as well. Right, and if you go back to the same Angular screen, what we have built, a different set of APIs, what we have built, right? And then if you look at it, let me bring up another application what we have built, right? I mean, so here in this case, the whole inquiry takes the data only from the the Yugabyte NoSQL database. It does not go back to mainframe at all. And then because the data is already pre-enriched, it is as much scalable. It gives the same amount of throughput what we can get from the mainframe. And if you can look at it from the network calls, you can clearly see that, right? I mean, it fetches from the locally deployed microservices, which gets the data back from the Yugabyte JSON itself. And then if I try to make any changes into that, automatically this Gordon calls the mainframe update APIs or the post and the patch APIs what we have created, right? And then we can also see the changes only in mainframe, and then it takes. So currently we have scheduled it for 30 seconds delay where mainframe data can be segregated. I mean, translated back into Yugabyte itself, right? I mean, for a near real-time data. So the kind of sync between mainframe and the NoSQL database depends on the business criticality, because certain fields business generally says that, okay, I just needed an end of day sync. In certain cases are near real time, and certain cases are, it works within every 2 hours or every 3 hours, right? We just define it based on the type of application, right? And if you look at it, the moment I do a update, it directly go and hit the mainframe URL itself. It is not going to be on Yugabyte, right? And then we can show it on the mainframe green screen itself. This update happens only there, but then with the low latency based update, it comes back here within no time. Whenever we define it as, based on the time interval what you define, immediately it updates back here. I can show that too. So let's quickly look at the mainframe. You can clearly see that the last name has been updated, right? So now let me go back to the inquiry services, which gets the data back from Yugabyte. And we can even show that, from the logs, the data has been synced up so that the data from mainframe has been synced back here. If you look at it, right? So the latest JSON structure, you can clearly see that it's been updated with Kennedy, right? And then, so let me do a quick inquiry on the Angular screen for the same SIM number what we have done, right? And then, so within no time, it brings the data back from Yugabyte itself, right? So this is a very popular use case which we see because of a couple of reasons. Because everywhere people are talking about highly scalable structure which is required for the inquiry functions, especially to serve the new age structures. And then, we also wanted to reduce as much dependency on during the runtime. Everything has to be pre-enriched and pre-stored into a presentable structure, right? And then this increases your runtime scalability to a great extent. And then we also wanted to talk about one more thing, which is like we wanted to reduce the dependency on mainframe and wanted to route as much traffic outside mainframe so that you can save your MIPS and other costs accordingly, right? And then there are also quite a lot of advantages when we talk about this. When people wanted to have a different security mechanisms with respect to your reads and writes, this works seamlessly. So these are all the different types of use cases that you wanted to talk about, and how the whole mainframe modernization story can work, in conjunction with Yugabyte's offering. That's all which we wanted to talk about. Any questions? And thanks for listening.